All right, guys, so in this video, we're going to be doing lesson 2, which is graphing circles in standard form. So if you remember, in lesson 1, we talked about the standard form equation of a circle, which followed x minus h squared plus y minus k squared equals r squared, where h and k combine to be your center, and then r is your radius. All right, so it's asking us for the warm-up, try and figure out what the center and radius are for each one of these problems. So this first one, remember how we said that in the equation, the signs are flipped for your h and k. So if it's x plus 4 and y minus 3, then that means your center is actually at -4, +3. All right, and then for the radius, so this number right here, this 144, that is your r squared. Okay, so in this case, r squared is equal to 144. So if I'm trying to figure out what my radius is, in order to get r by itself, I need to square root it. So if you take the square root of both sides, you're going to find that r, in this case, would be equal to 12. So our radius for this first equation is the square root of 144, which is just 12. All right, next one. X minus 5 and y minus 1. That means my center is at +5, +1. My radius is the square root of 75. Okay, so square root of 75, which if you simplify it, it might be like 5 root 3. Okay, as a decimal, it might be something like 8.6, 8.7-ish, somewhere around in there. Next one, it says x squared. There's no number with it. That's the same thing as like x minus 0 squared, right? So my coordinates are for the center are going to be 0 and then -2, because I have a +2 in the equation. My radius is going to be the square root of 81, which is just the same thing as 9. And then the last one, x minus 3, and then y squared. That's going to be +3 and 0 for the center. My radius is going to be the square root of 50, okay, which is the same thing as 5 root 2, or maybe about 7.1. Okay, so square root of 50 or 5 root 2 or 7.1. I'd take any of these as your radius. All right, now it says write the equation, standard equation of a circle centered at 2, -4 with a radius of 3. Sketch the graph of the circle. So we're doing the same thing we did yesterday, only at the end, we're going to draw a picture of the circle. So what I want to do is create the equation first, okay? So let's write the standard equation of the circle. So I'm going to have, remember, x minus 2, because we have a +2, so it's going to be -2 in the equation. So x minus 2 squared plus y plus 4 squared equals radius of 3. That means the number right here, this is r squared, so 3 squared, 3 times 3 is 9, okay? So that's my equation. Now, if I want to draw it, first thing I'm going to do, I'm going to plot my point for my center. So I'm at 2, -4. So I come over here, 2, and then down 1, 2, 3, 4. So there's my center. And then my radius is 3. So I'm just going to go out 3 units. 1, 2, 3. Go out 3 units. I'm just going to go out in 4 different directions, just so that way I have points to trace. I'm just going to trace along these points. And so if I draw those points, your circle doesn't have to be perfect, just kind of roughly shaped where it's supposed to be, okay? All right, so this one says a hospital is located 5 miles east and 6 miles south of the city center of a city. They have contacted Jackson Healthcare to provide a temporary inpatient care for patients coming from ER visits. Mrs. Smith lives 4 miles west and 7 miles north of the city center, and sits on the edge of the coverage area allowed for temporary inpatients at the hospital. Assuming the center of the city represents the origin, provide a standard form equation of a circle to represent the coverage area for short-term care doctors. So I've already gone ahead and labeled these. So this here in the bottom right hand corner, this is our hospital, right? And then it's telling us that Miss Smith lives here. So it told us the hospital is 5 miles east. So 1, 2, 3, 4, 5. And then 6 miles south. 1, 2, 3, 4, 5, 6. Same thing with Miss Smith. 4 miles west. 1, 2, 3, 4. And then 7 miles north. 1, 2, 3, 4, 5, 6, 7. All right, now, assuming the center of the city represents the origin, provide a standard form of the equation of a circle to represent the coverage area. So if I'm looking at this graph, I need to know, like, this hospital is my center of the circle. All right, I need to find two things. I need my center and my radius. So the center is at 5, -6. That's where the hospital's at. But the radius, I don't know. I don't know the radius. So I do know that Miss Smith is on the edge of that circle. So this is going to be our radius. So if I could just find the distance between my center and Miss Smith, which is at -4, 7, then I find the distance between these two, I'll have my radius. All right, so I use the distance formula. Remember, square root of x2 minus x1 squared plus y2 minus y1 squared. And you take the square root of that whole thing, right? So if I plug all of these numbers in, I'm going to have x1, y1, x2, y2. So I'm going to have -4 minus 5 squared plus 7 minus -6 squared. And so I'm going to have -4 minus 5, that's -9 squared, plus 7 minus a -6. That's really saying 7 plus 6, so that's going to be 13 squared. Simplify further, -9 squared is 81. 13 squared is 169. Add these together, I'm going to get the square root of 250. So my radius is equal to the square root of 250. And so when I combine these two things, my center and my radius, when I combine these two to create a circle, I get an equation that looks like x minus 5 squared plus y plus 6 squared equals r squared, which is just 250. Remember that radical goes away when you square it. And so I've got my equation for the circle. And then the next question says, could Miss Smith's friend, who lives 6 miles west and 3 miles south of the center of town, work at the hospital? What strategies are possible? So I need to see if she is within the limits of this hospital's radius. So what I'm going to do, it tells me that her friend lives 6 miles west and 3 miles south. So her friend is basically living at -6, -3. Okay? So if I plug these in to my equation, let's see what we get. So I have -6 minus 5 squared plus -3 plus 6 squared equals 250. And I'm just going to simplify this. -6 minus 5 gives me -11, still squared, plus -3 plus 6 gives me 3 squared equals 250. -11 squared is 121. 3 squared is 9. And so I'm going to get 130 equals 250. Now, you might be thinking, well, that's not accurate. 130 doesn't equal 250. And you're right, it's not. But the way this works is that we know that this number, this 250, represents our radius, right? So anything that is less than this number on the right means that it's sitting inside that circle, okay? So it's sitting shorter inside this circle than, say, Miss Smith, who sits on the edge of the circle. So if you have, there's three different ways that this could work out. You could have the left side of your equation be less than the right side, like we have right here. You can have the left side be equal to the right side. Okay, so in that instance, it would be 250 equals 250. Or you can have the left side be greater than the right side. So you might have something like, this left side might be like 400. That would be greater than 250, right? So if the left side is less than the right side, that means that you are inside the circle. If you are equal to each other, that means you are on the circle. And if you are greater than the right side, the left side is greater than the right side, then that means it is outside the circle. So you might have problems that ask you, is this point inside, outside, or on the circle? You need to know how to determine that. All right, so it needs to be falling into one of these three categories. Okay? All right, so that's all the notes we have for lesson 2. The practice is just page 9, so you need to complete all of page 9 for practice. And then when we get back together, we'll do lesson 3.